What happens after I teach this? People generalize up and you can't. So I've got this circle. We've been talking about, so let's make sure you know the difference between central and inscribed angles. It'll come up in your vocab, so if you want to draw this off to the side, it'll be helpful. So central angles, literally the name central angle tells you where it is. It's in the center of the circle. Check, check, right? That's our central angle. I highly suggest put it in this section. Remind yourself, this is a central angle. And then we've been going crazy with this idea, because if you know that this angle right here, I don't know, kind of looks like 90. If that's 90, what's the measure of this arc? 90. Okay, so we've learned that. Today's is different. Be careful. Central angle, again, literally goes off the center of the circle. Today's an inscribed angle. An inscribed angle looks like this. It's off of the edge of a circle, and then it cuts an arc. Like that. So your very first vocab, page 216 is inscribed angle. This is an inscribed angle. So make sure you have the difference between the two down. I'm trying to think if I want to give away. Yeah, might as well teach you right now. Are you ready? So central angle, it's the same. The angle of the arc, it'll be the same measurement. What do you think about inscribed angle? What will be the same? It's increasing. It's getting bigger and bigger and bigger and bigger. And I guess it's how much bigger it will be? I heard it. It is. I don't know. What does that look like? Should we just say like 70 degrees? If that inscribed angle is 70 degrees, this arc is double, 140 degrees. I hope that's logical, because it starts on the edge and then it grows, it gets bigger and bigger. So don't mix up these two. What happens is people generalize, and they start doing inscribed angle 70, arc 70, or they'll do central angle 90, central arc 180. They just mix up the two. So know the differences between the two. Okay. All right. If you want to put in words, an angle whose vertex is on the circle. If it was my notes, I would probably just put this much. Vertex on the circle. Just where that's an inscribed angle. Okay, intercepted arc, because it's the same thing, only inscribed angle is focused on the angle, arc is focused on the arc. So it's the same picture. So going back to this 70 degrees is the inscribed angle. This piece right here is the intercepted arc. It's the same picture, just a different focus. Okay, this one, I suggest writing it down, because I have to read it and then think about it. Same with this one. Maybe write it down and then we'll talk about it. So inscribed polygon. Polygon whose vertices all lie on a circle. Circumscribed circle. A circle with an inscribed polygon. It's the same picture, again, focusing on different parts of the picture. We'll do our best and we'll sketch it in just a second. Okay, while you're writing down, does anybody remember, if we break up that word polygon, do you remember what poly stands for? It is many. Way to remember. Do you remember what gon, G-O-N, stands for? Sides. Many sides. So any shape that fits inside a circle, but its edges are on the circle, that's an inscribed polygon, as long as it has straight edges. Okay, are you ready? Just off in your margin, get ready to draw a picture. I suggest doing the circle first. There we go. And then we'll just start. Shape tool, I've got to have it out. Pentagon? I don't know if I can make it work. Okay, so pentagon, it's got to have its edges on the side of the circle. Okay, maybe I'll just adjust it. This one. Okay, I'm just going to cheat. Check. Check. Okay, technically, is that a polygon? It has straight sides, right? Are all the vertices on the edge of the circle? Okay, so to get these two clear in your head, right here, if you're looking at the circle, what's the vocabulary we would use to describe the circle? It's a circumscribed circle. So the circle, the blue part, is circumscribed circle. I know you don't have blue in your notes, but okay, if it asks you to describe The pentagon, what would you say? It's inside, that's how I remember, it's inside a circle. So this is an inscribed pentagon, or you could just put polygon. Okay, nod your heads. Did those two make sense? Okay, they are hard to draw with actual tools. Okay, next part. I think I already taught you this. Let's see what's next. Oh yeah, I already did. I don't love this picture because they still have the central angle in there. This theorem is saying what we just taught on your vocab. Saying if you have this inscribed angle, this arc is going to be double it, right? Okay, what if I give you the arc? What if this arc is 60 degrees? What's the angle? Easy enough? Okay, this next one I really like. I've already told you that I like to draw on stuff. I actually got in trouble for drawing on stuff when I was your age, but I just got bored and I would highlight stuff to help me remember. So this one, if you highlight it, it comes out. So if you start with angle C and you trace it, I suggest tracing it on your notes. So angle C is right here. Guys, is angle C an inscribed angle or a central angle? Okay, it's inscribed. Good work, because it's on the edge of the circle. So there's the angle, and it cuts this arc that I highlighted in green. That arc from the circle. You okay with that logic? Well, it's saying go to D. Trace D and something's going to happen. So if we trace the inscribed angle D, what do you notice? It cuts the same arc. If it cuts the same arc, what do you think has to happen with those angles? They're the same angles. So that's what that's saying. And I hope that's helpful. So C is 30, D has to be 30, because both their arcs would have to be 60 degrees. That comes up on this section too. Okay, next part. If you don't love this, don't worry about it. I don't care if you just write on the picture. Go for it. Try it. Work, way to move those bodies. Letter A, what's the measure of that inscribed angle? Totally, right? Angle Y, 70 degrees. All right, letter B, what's that arc? You okay with that? Okay. Another thing that I noticed happening in this chapter when we go through quizzes or tests is people get it backwards. Like they'll say this is 80, but this arc is 40. Be careful with that. I hope it makes sense that it's got to get bigger. Okay, next one. This one, same thing. If you don't love filling in these blanks, I don't mind. Just look at your picture. This is a trace it out. Something's going to happen, but trace it first to be sure. All right, guys, shout out. What is it? It's got to be right. How many of you actually traced it? Did you trace it, whether it's in your head? Yeah, they'll cut the same arc. So if you look at angle Y, right here, cutting this arc. And then if you trace Z, it's cutting the same arc. They have to be the same. Next part, you got this. Go for it, try them. All right, here we go. Number 1 on the checkpoint, I just want the girls. Girls, tell me what you got. 44. Yeah, good job. Number 2, boys, what'd you get for this one? 42. Oh, way to be louder. Everybody, what'd you get for number 3? 38. Same, right? How many of you, I got those concepts, those 2 concepts. Pretty nice, right? Okay, this one comes up in your assignment. One whole picture is this. And students in the morning class missed that it was this concept. So right here, it's saying if a right triangle is inscribed in a circle, stop, review. So inscribed means the edges are on the edge of the circle. Do you agree? Okay, so definitely inscribed, that's the center. Then the hypotenuse has to be the diameter. Okay. Well, first we have to know that it's a right triangle. I'm going to make the font a little bit smaller. So add it in. That has to be a 90-degree angle. This is what was inferred, but people didn't realize it. So will you stop where you're at and look at the board? Right here, I'm going to change up the colors. If that's 90 degrees, do you agree technically that 90-degree angle is an inscribed angle? You okay with that logic? So if that's 90 degrees, what's this arc? Okay, 180. Just keep that in mind. It comes up on your assignment. Okay. Yes. Thinking. Okay, so this is saying if this is a right triangle that's inscribed, this has to be the diameter. And it's what Ellie was just saying. It's going to be forced to be the diameter because it's going to be that 180 degrees around the circle. And then just remember the converse is true. If you have a triangle inside a circle and it goes through the diameter, it has to be a 90-degree right triangle. Okay. All right, theorem 1011. I always forget this. And so when I make your keys for this section, There's questions that say, can you draw a circle around these polygons? I'm like, I don't know. Can you? Like, good luck, probably. And I just eyeball them. I forget that there's an actual rule you can follow, so just put a box around it. In order to tell if you can put a circle around a polygon and make sure you hit all the edges, right here, this is what you check. Put a box around it. You have to make sure opposite angles are supplementary. What does supplementary mean? Right here. Fill it in. Add up the opposite angles, they have to add up to equal 180. If they do, then it's possible to draw a circle around them. Okay, now back in the day, I used to hand out polygons and students would have to make the circles around them. But we can't use that tool anymore. Do you know what that tool is called? Compass. Now we can't use those specific tools that I used to use. Do you know why we can't use those specific tools? Sharp point. So it's the kind where it has a sharp point and then the pencil attached like this. Twist around, but it's just dangerous. Can't trust you anymore. So there's safety compasses, but they're not so good. So just keep this rule in mind. Opposite angles have to be supplementary in order for you to be able to do an inscribed polygon. This one. Stop and think about this. Is this an inscribed triangle?
Yeah.
Its edges are on the circle. Does it go through the diameter?
Yeah.
So what does that say about this? There you go. Set it up. Set it up. Grab your calculator. Set it up. Help me out. What's 90 divided by 15? 6. So x equals 6. Okay, be careful in this chapter. I like train myself to go back to the directions because this chapter is king of saying one thing and then you solve for x, but then you go back to the directions and it says actually find the angle. So just be careful. Just get used to double checking the direction. So is that an inscribed polygon? Its edges are on the circle, so it's an inscribed polygon. How are we going to find x and y then? Okay, let's help what you're going to do. So opposite angles have to be supplementary?
Yeah.
Caitlin, do you want to take it further? Literally, what are you going to set up?
So if we're find x, we do 18x plus 72 equals 180.
Nice. Good work. Those are definitely opposite of each other. Okay, guys, go for it. Solve it. Help me out. What did you get for x?
6.
Did I do that right?
Yeah.
Okay, so x is 6. What did you get for y? 3? How many got that way before? Still on the board. You okay with that concept? Okay.